All right, we have one last method, and that is solving systems by elimination. So we've discussed when to use elimination. We use elimination when we have two equations where neither one is solved for x or y, where both x and y are on the same side of the equation. Okay. We want them to be able to be stacked like these are right here, x over x, y over y. And then elimination, sometimes also called the adding method, because you really just add the two equations together. But in order for this to work, two of the coefficients have to be the same number with opposite signs. So here we have 1 and 1 in front of our x's, but that is not opposite signs. So we move over to y, we have positive 2 and negative 2. Those are opposites, the same number with the opposite sign. So these two equations are ready to go. We just draw a line and add straight down. Our goal is for something to eliminate, hence the name elimination. So here, x plus x is 2x, but then 2y plus negative 2y, that's 0, that's gone. Break down our equal sign. 6 plus negative 2 is 4. Divide both sides, and I get x equals 2. And then from there, it's just like substitution. Pick one of the equations and plug it back in. So the top equation, where x is, I'm going to put a 2, plus 2y equals 6. Subtract 2. I get 2y equals 4. Divide. And I get y equals 2. So my solution here is number x comma y. So it's 2, 2. Moving over to the next example. Once again, our x's are not opposite signs, but our y's are. Negative 1 and positive 1. Remember, if there's not a number written, the coefficient is 1. So these two are ready, and we can add straight down. We're not always that lucky, but we'll discuss what to do when we get there. X plus x is 2x. Here, those cancel. We have equals. Negative 1 plus 17 is 16. Divide by 2, and I get x equals 8. Then I can plug it back into either equation where x is. So I have 8 minus y equals negative 1. I can subtract 8. So just plug into that top equation. So I took where x was. And instead of x, I put 8. Now we're subtracting that. And remember, to get rid of that negative, you just divide by negative 1. So y equals 9. My answer is 8, 9. It's the solution to my system. See if I can draw a better 9 there. Maybe. Alright, moving down here. We almost have that same setup, but not quite. Here, if you look, y is the same number, they're both 1, but they're not opposite signs. So to fix this, I can multiply either equation. By a constant, by a number, all the way through. So I would like this to be negative 1 here. So I think I'm going to take, or maybe here. These are negative, so if I multiply by negative, I'll make them positive. I like that better. I'm going to multiply this by negative 1. Okay, that'll give me positive 2x. Negative 1 times y would be negative y. And then negative 1 times negative 1 is positive 1. And then I can add straight down, adding these two equations. So this one just came from here. Adding these together, I get 3x equals 6. Lots of really nice 2's, huh? That gives me x equals 2. And then I can put it back into either equation. So maybe I like the bottom one. I'll do x plus y equals 5. Well, if x is 2, hopefully we can see that makes y 3. If not, subtract the 2 over y equals 3. So we have 2, 3 as our solution. Alright, we got a couple more. Let's look at this one here. This one is nice. These are opposite signs. It's 2 and 2, and we have positive and negative. So that's ready to add. So I'm going to add straight down. And those cancel. 2 plus negative 2 is 0. Oh, but here, 2 plus negative 2 is 0. And here if I add, I get 12. Okay, we know that 0 does not equal 12. These are not the same. So this is what no solution looks like for elimination. Okay, now we have one more example here. This one we're going to have to do just a little bit more work. We look at this. These two are not the same number with opposite signs. These two are not the same number with opposite signs. But I can make it that way. If I want this to be 4, so that I have positive 4 and negative 4, all I'd have to do is multiply this by 2. So multiply the whole equation by 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 6 is 12. Okay, then adding straight down, negative 4 plus 4 is 0. Negative 6 plus 6 is 0. Negative 12 plus 12 is 0. Okay, so this is a special case also, like the last one, except this is true. 0 does equal 0, always and forever. So that means we have infinitely many solutions. Okay, that means those are the same line stacked on top of each other. So they cross everywhere along that line. So there are infinitely many solutions. Okay, so just like with substitution, if you end up with something that's not true, it's no solution. Something that is always true, it's infinitely many solutions. Otherwise, you should get one unique solution like the first 3 here. Remember to write down any questions that you have and try the last 2 problems, and we will discuss them in class. Please let me know if you need any help. Thank you for watching.